Okay, so it's 3 o'clock. So let's get started. So this is Math 115, which is intro set. So I think right at the outset, let me just say, although this is a math class, there's actually very little math in it. If you, because I don't count arithmetic as math, all right? So in case you've heard things about this class, let me try to dispel your fear. Okay, this class is really not very mathematical. There are concepts, but it's not about the math. All right. So let's check out the syllabus. It's there. I don't recommend you print it out because it's kind of long. Um, but I will point out a few things on it which I think are important. First of all, the class uses a free textbook. I don't refer to it very much. But if you are the kind of student that likes to learn from reading a textbook, uh, please let me know, and I will point you to approximately where in the book we are, because my chapter numbering doesn't follow what the book does. So when I say chapter 2 in my notes, it's not chapter 2 in the book, just so you know. So if you like to read books, you want to read more, I welcome that. Let me know. And then I'll do like a mapping document and put it on our page so you know where we are uh, relative to where we are in class. All right. So that's the textbook. The other thing I want to point out is my office hours are there. You can see them displayed. If you cannot meet any of them, let me know and I will set up a time that works for us both. Okay, that's always fine. Let me know. All right. If you come during office hours, you don't need to make an appointment. Just drop in. If I'm with someone, then obviously just wait around. If my door is closed, then just knock. Don't feel I can't disturb the professor. My door is closed for logistic reasons because I am at the intersection of two hallways. It gets pretty noisy, so that is why I close the door. I don't close the door to chase people away. All right. So if you come and you see the door closed, just knock on the door. All right. What else is there to say? Yeah, the syllabus gets bigger and bigger as the years go on. Okay, let's point out a few things. Okay, there is homework in this class, obviously. It's all on the computer, so you don't actually turn in pieces of paper anymore. But I will point out something quite important on the homework. And I'll talk about this next time as we do more, get deeper into the course. The homework is done on an interface outside of Moodle. It's on a site called My Open Math. You don't need to know all that. You just go to Moodle and click on it. It will bring you there. You don't need to register, nothing. The only thing is, students typically want to know how well they've done on the homework. So you need to go back to Moodle to check your score on the homework. It talks to Moodle that way. You don't see it directly on My Open Math. And give it some time. So if you make a change, that change in your score is reflected in a couple of minutes. It's not immediate like that. Sometimes it's a little bit too late. So bear that in mind. The other thing is, I do give, it's not unlimited. It's 100 tries. So every homework you can try 100 times before you run out of tries. Okay. So this is particularly useful because I have all kinds of students. Some students really, it is a thing for them that they want to get 100% for every homework, and that is commendable. It's good. Not everyone's like that. Some are. So let me from the start tell you how to become less frustrated when you do the homework. Because some students have told me that it's very hard because I don't know what I got wrong. And I can't let the homework system tell you what you got wrong because some questions are multiple choice. And you know how, if it's multiple choice and there's true or false, and you know true is not right, then what kind of learning is that? So that is why I don't, the system doesn't tell you whether you got something wrong or right. The way to know if you're on the right track is to check your score on Moodle. Now, to make sure it's not a frustrating exercise, if it is very important to you to get full points on every homework and not to be frustrated, this is my recommendation. Make sure you do your homework problems sequentially and do not leave the problem until you know you've got it right. Now, what do I mean by this? Let's say there are 5 problems on the homework. You do question 1, then you do question 2, and 3, and 4, and 5. And it's what we usually do. Then you look at your score. It's not full. Something's wrong. That's where the frustration mounts, because it's like, okay, where's the wrong part? Now, if it's an easy question, you can find it quite quickly. So my recommendation is do the homework problems sequentially, and if getting full points for everything is your thing, make sure that before you leave and attempt another question that you have scored the full point possible for that homework. Do you get what I'm trying to say? This will minimize the time you spend on your homework. So don't randomly jump from question to question like that, because then it's very hard to identify exactly where you got something wrong. Now, of course, if you really are stumped and you just can't figure it out, then you can let me know, and I'll take a look and see where. But this should help you get out of the jam, because some students say, oh, it's very frustrating. It's like, you can never please all students. The other way is to make it one attempt. One attempt, you go in, you try, you get out. You can't improve on your score anyway. I don't think that's fair either. So I think this is the best way I can suggest. The other thing I want to point out is it is very important that you make sure you submit every time you do a homework assignment. Why is that? I've had students in the past who would tell me, you know, you get these emails. It's actually these kinds of emails that make professors die, right? And that's why my hair's so white. What does it sound like? Oh, Professor Cole, I was doing all my work, and then now when I go and look at it, time's up, the assignment was due, it shut down, and I see nothing there. I used to be really puzzled why that is the case. I actually thought that the students were pulling a fast one, they didn't do anything. But then I realized, to my horror, that it's not that the answers were there. They got recorded in a separate receptacle that doesn't get counted. It is there. So to avoid all this, please make sure that you hit submit whenever you are done with your homework. Don't let it time out without submitting. That's very important. Submit, submit, submit. Okay? Now, again, this tended to happen with students who do their homework right at the last minute. And so, when you're running out of time, you don't think to submit. You're just trying to beat the clock and get all the answers in. So they did not hit submit, nothing got recorded. Students who did it a day or two before it was due didn't have this problem because they did submit. They wanted to see their scores anyway. So this tended to happen with students who took the course less seriously, I would say. Not saying that it's wrong, but that tended to happen. So my advice to you is hit submit. You have 100 attempts anyway. You're not going to run out of submissions, so hit submit. All right? That way, everything you've done gets recorded. Okay, the other thing is also screenshots are your friend. So if you really feel that you did something and it just didn't get recorded, if you had a screenshot, at least I could look at what you've done. So, but I think if you hit submit, that should solve the problem. Okay, so that's enough about the homework logistics and all that. I think midterms has nothing to talk about. Their exams and stuff like that. There is a project at the end of the semester, so not yet. And it's a group project, so you work with people in your groups. In fact, group work is a pretty big part of this class. And usually, people work in the group that they are naturally at right now. Now, today being the first class, I will not count it. The group work that you do today is not counted in the sense that I'm not going to do it for credit. Because I know sometimes students want to sit with their friends or whatever, and I'm fine with that. I'm not the kind of professor that says, oh, I'm forcing you to sit with people you don't know. I don't care, right? You can. So this being the first class, maybe you didn't know someone else was your friend who was in this class. So, but make sure that next class, you sit with who you want to sit. And that will be your group for the rest of the semester. You know what I'm saying? If you don't know anyone, fine. Then the default group now, which is at your table, becomes your group. That's okay. Why is this important? Because not only is this group going to be your project group, it is going to be your go-to group work buddy system thing throughout the semester. And knowing human nature, there are always some people who take the course more seriously. And that is why you will, at the end of the semester, do some kind of evaluation of your other group members. So what do I mean by this? So let's say there's 3 of you at this table, all right? And 2 of you are okay, but there's one person who just doesn't come to class. And when you don't come to class, how are you going to contribute to the group work if you don't? And so throughout the semester, you will have your perception about how much help this person has been. And so you will have the opportunity to evaluate each other at the end of the semester. Not just for the group work, for continual group participation. And this is also so that you all will share out the load whenever there's group work, and there is a lot of group work. Now, the good news is I give group work in many forms. The group work that will take place on Moodle is for credit, but you do it in your group. You can discuss. I also have found that these are very, very effective and well liked by students. I give out physical group work like this on paper, which I collect back and look at live in class so I can interact with you about it. These are by completion. Why do I do that? Because I don't want you to be afraid of, oh, I'm going to get it wrong. I just want you to do your best on this, fill everything in. It's by completion. And there'll be many of these assignments throughout the semester. So these are part of the group work as well. They count towards your group work, but they're all by completion. That's what I'm trying to say. All right. So today is no exception. We will have some as well once we're done talking about the syllabus. Okay. Anything else of interest? Okay, final exams are already stated by the registrar, so you can see there is a final exam. The times are there. I'm always afraid there's something I'll mention it if I think I've mentioned most things that I want to say. The schedule, this is approximate. There are 2 midterms. I think only one other thing requires me to say something, which is I've never had to say this, but I've had some classes where there were 1 or 2 students, not all of them, 1 or 2, who habitually talked to each other throughout the semester. It really got really difficult to teach the class because it distracts from other students. It distracts me as well. It's also kind of disrespectful. So I would say, if you are discussing something about stats, go for it, of course. I'm not going to stop there. But I don't think these people are talking about statistics. I mean, I couldn't hear, but you know, human beings don't just communicate just by listening. You also see body language. Clearly, they're talking about non-statistical things, right? So don't do that, right? Don't do that. And also, you know, try to minimize browsing on your phone. I know it's impossible to live without our phones now, but try to minimize that and use it for legitimate things in class as well. So this class that you are experiencing with me is actually, I would say, I'm not trying to plug what I've done, but I think this class has been very, I've taught this many times. And you are at the receiving end of, I think, 10 years of me teaching this class. So it has only gotten better with time. And so I think you're going to have a good time, honestly. Because I have, I guess, discovered what is most important and to be focused on and really cut down on things which I feel don't help. So this should be okay. The only thing I want to mention is if you have a challenge when it comes to doing arithmetic on your calculator, you must come see me. Then I'll help you. You know why? Because I don't want arithmetic problems to be a source of a disruption for your understanding of this class. Because I've had students, the whole spectrum. Some have absolutely no issues with arithmetic, and there is some that you need to do in class. And it became a stumbling block to their progress in the class because they are struggling or grappling with the arithmetic part of the course, which should not be the case. So today, I will open up a homework for you to try. That will be basically an arithmetic exercise. Now, I know for some of you, you may think this is so dumb. Why am I doing that? Because I have learned that there are students who find these things challenging. They don't know how to do it. So if you find that you don't know how to do today's homework, please come see me. Right? For office hours, I'll help you. Right? Because I don't want math, arithmetic issues holding you up. Okay, I think that is all I have to say about the syllabus. So let's just get started. So I have my notes, and I did ask you to either get it on your machine or print it out. Where again, this is something I found students have liked. I teach using notes that are like 80% there, a little bit left for you to fill in. Why? Because I found that giving complete slides all the time actually sometimes makes students more passive and they don't interact as much. You learn by writing, believe it or not. Trust me. Okay. I'm older than you, and I can tell you, I have also learned by writing. You do learn by writing some stuff down. Now, sometimes there may be occasionally a lot to write. Do I allow students to take photos of the screen? Yes. Do I publish the completed slides at the end of class? No, because I want you to fill these things in. If you take a picture of the screen because you didn't have time to finish the notes, that's fine. But please make sure that at the end of the day, or at least at the end of the week, you fill in your notes. You know why? At the end of the semester, how many photos do you have in your phone? 1,576. Try finding slide 6 from week 3 of my, okay, good luck with that. So I don't mind you taking pictures of the screen. If you find that you want to listen to me, you want to write, the best is actually to write along, I would say. When I say write, I mean either on your device or physically. That's up to you. But if you must take a picture, you can, but keep up to date. Okay, so what is statistics? Well, statistics with a capital S is a science. It actually helps you draw conclusions from data. Part of it is looking at data, and we'll do some of that. But this is an intro class, so we're not going to focus a whole bunch on tremendously complicated displays for data. I think that's for another course. I will teach you, we will see some today, some pretty simple displays you can learn how to generate. So statistics is a science for looking at data, but more important than that is to draw conclusions from data. Okay? Now I'm sure you all have heard of anecdotal evidence. What's the contrast between anecdotal evidence and a proper statistical investigation? Anecdotal evidence comes from personal experience or some striking example, right? Everyone knows what this is. Oh, my friend uh, never sleeps more than 2 hours and he's doing fine. That kind of thing is anecdotal evidence. It's just your friend. How you have not tested this on a sample of people. So it can be from personal experience or some example, and can be problematic. Why? Because the data are collected in a very biased way. Anecdotal evidence, by definition, are from people you know or stories you've heard. How much more biased can that be, right? Right? It's from you. So therefore, it is very dangerous to make conclusions based on anecdotal evidence. But don't we see that all the time, right? And done by all kinds of people, whether it's people who are not in positions of influence or very much in position of influence. It's very tempting to use anecdotal evidence uh, to back up what you're saying. It can be problematic because the data are collected in a very unplanned way, or worse, right? You cherry pick a case. Like this supports my agenda, so I'm going to quote this example. Examples which do not follow what I think, I hide, like that. Now I'm talking about the ethics of it. That's actually very unethical, but that's why anecdotal evidence is very dangerous. I'm not saying it's not fun. It's fun, but it's very dangerous. All right. Statistical investigation is a rigorous framework, and it's systematic and can be verified. Right? It's reproducible. Right. Okay. Let me give you the first example which I can think of why you need to be in this class. So I don't know what your perceptions are about statistics class. I think if I ask for a word cloud, you'll probably say things like numbers, calculations, hard, formula, boring, yeah, high school, whatever. Okay, there's so many things you could say. Uh, but I wonder whether anyone knew that statistics actually is about making good conclusions from data. That's basically it. And before you can come to a good conclusion, you need to know how your data will collect it. What do I mean by this? Okay, so think of a simple, and you can see it in your slides. I'm not shifting to that, so I'm giving you more time on that one, but you have it in your slides. I'm going to talk about something which I think most of us would understand. Now, it's not dry now, but as winter comes, it's going to be, right? And I don't know whether you're from here. I'm not from here, but I've lived here long enough. The winters here are pretty bad, right? Sorry, right? That's just how it is. Last one was 2024, 25 was very cold. Okay, it's very slow. But the thing I'm going to talk about now is it gets really dry as well. And your skin tends to flake and all that. So what do? We try to put some kind of moisturizer or lotion or something like that. So don't you want to know which one works better? Right? Let's say there's two brands. I mean, there's more than two, but let's say you're comparing to A and B. You want to know who is better. Okay. Now, before you can know whether something is better or not, there has to be some metric for you to evaluate the performance of a hand lotion. So let's say there is a way to calculate how moist your skin is. This may be a thing. I don't know. Things progress so fast now. But if it's not, let's pretend it is. Right? There's a moisture meter or something that you can actually put and get a quantitative measure of how moist your skin is. Let's say there's such a thing. Okay. So I propose two ways of determining who's better. So study design number one says this. I divide the sample of subjects that I have into two groups. One group only applies lotion A on both arms. Another group only applies lotion B on both arms. Now, I know in this room there are more people on this side of the room. And so that makes the math a little bit complicated. Let's pretend that there are equal numbers of people on both sides of the room. So what I mean by this is the people on this side only do lotion A, and they put lotion A on both arms for a prescribed period of time. The people on this side of the room only do lotion B on both arms. Okay, let's study design one. And after a month or something like that, I go measure everyone's skin moisture reading, and then I can determine on average whether A or B is better. Okay, that's one design. The other design is everyone in this room gets access to both. So you do lotion A on one arm and B on another. And so to keep things easy, let's say I say you put A on your left arm and B on your right arm for a month. And at the end of the month, I'll measure all the moisture readings. Okay, so my first question to you is this. If you think about the problem carefully, and remember I did say assume that there are equal numbers of people on both sides of the room. Do I, at the end of the month, actually get the same number of lotion A readings and lotion B readings? Think before you answer. Do we get the same? Do I get the same number of A readings and B readings from both designs? Yes or no? Think carefully. How many of you say yes? That you actually end up with the same number of A readings and B readings, right? Same, assume that there's 10 people on this side and 10 people on this side. So look at the setup again. 10 people on this side, 10 people on this side. In design one, all 10 do A on both arms. And here, all 10 do B on both arms. In design two, there's 20 of you, and everyone does A on the left arm, B on the right arm. So listen carefully to my question again. At the end of the month, do I get the same number of A lotion readings as B? Yes or no? Is it the same? What does that? What do you think? Right? The same or not the same? In other words, do both designs yield the same amount of data, if you like? So I see most of you saying no. The answer is actually yes. Why? Okay, yes.
Because it's the same number of arms.
That's right. Everyone has two arms, right? I did check. Yes, I think so. Okay. Okay, that was an assumption I made. Okay. Good. The number of arms is the same, which means One design and another is not better than the other because it yields more data. The number of data points is the same. Now let me ask you this question. Which design is better? One or two? Anyone? Yes.
The two.
It is two. Why?
Because different skins have different reactions.
That's right. And what's the problem with that? If everyone on this side does A, maybe coincidentally everyone on this side has really moist skin anyway. They could take sandpaper and scrape their hands every day and still win on the moisture level. You know what I'm trying to say? So, if your goal is to determine which lotion is better in terms of making your skin moist, it is actually better for everyone to do both because then you are your own control. It is fairer to compare that way. So you see, this is what I mean by thinking carefully about your study design. Your study design it's not going to give you more. Doing one or the other is not going to give you more data. It's how you use your resources that you have. Okay. The even study design tool, although better than one, there are still some issues with study design tool. Can anyone think of an issue? In other words, is there something that study design tool has assumed which may affect the moisture level of your skin or the calculation of the moisture level that does not take that into account? This is a nice question. Yes.
Like how much lotion they apply.
Oh, okay, that's good. I did say, right? Okay, so let's say everyone uses a prescribed, I give it to you in a small bottle. Okay, good. So let's standardize how much lotion someone uses. Can anyone think of a problem with that? Actually, I'm going to give you a hint. I'm going to say it again. The protocol was left arm A, uh, right arm B. Okay, so anyone have any issues with that? Study design to say that? Yes. Correct. I have assumed that everyone is either left or right hand dominant. Because maybe your dominant hand, mine's my right hand. So maybe there is some evidence that your dominant hand tends to get drier because you use it more. See? So what I'm saying is even study design 2 has its issues. And what you need to do would be to say, you have to split it, So some people would put A on their dominant arm. So the issues get more, and the more careful you want to be, the more difficult the design and more sophisticated the design has to be because you want to be fair. See? And so these are things to consider. Now, of course, it's easier to implement design one, of course. Who wants to fiddle with two kinds of lotions? People may make mistakes. It's just harder. Isn't it easier to just dump things without thinking who's getting what and things like that? So I'm not saying that the best design is the easiest one. I mean, most things in life, the better thing is usually the more difficult thing anyway. So that those two are not related. Usually, the better design needs more work. All right, good. So the sky is the limit. And can you propose an improved design? I told you have to consider dominant hand and things like that. And as was also pointed out, I'll soon know who all of you are. So I'm sorry. This is my first class. Yes, you need to standardize. How much lotion are you using? How are you putting it on? Right? Yeah, so all these things have to be addressed. Very good. Almost, and I put that in parentheses, almost every data set has variability. Why do I say almost every? I'm sure you can go find one that doesn't have any. Okay? But by and large, every data set has some variability. You don't get the same number all the time. If I ask you how tall you are, I'm not going to get the same answer, clearly. So there's already variability there. So almost every data set has variability. And even a summary statistic that you compute from a sample has variability. What do I mean by this? Well, a summary statistic is a statistic that summarizes a sample. So let's say I got everyone to tell me how tall they are, and I compute your mean height, the average. I think everyone knows how to compute an average. That is something so universal, I never have to teach it. All right? So I can get the average height of people in this class. If I went to another classroom right now and got the average height, do you think the two numbers are going to be the same? No. So not only is data variable. Even summaries of it are variable. Now, this is a very important concept that you must get across. There are two things: data and numbers that you summarize the data from. Things like the mean. Okay, so there are two distinct things, but both are variable. Okay, so if I ask each of you what kind of height you, how tall you were, what kind of height? Okay, what kind of data? What kind of data would I get? Well, something like this. So I don't know whether you think in terms of inches for height or feet and inches. I don't like writing feet and inches because that requires a little bit of arithmetic before you can use it, right? But anyway, I converted it to inches here. Um, or maybe you think in centimeters, that's up to you. But you might get something like this, okay? How would you display data like this? Can you give me a word? Anyone heard of anything from your past? Yes.
Mean.
Oh, that's very good. We are going to talk about mean. The mean is a numerical way to summarize this. Very good. But display. Can you think of a picture? What picture have you learned about in your school, in high school, maybe even middle school, that was associated with looking at data like this? Anyone? Yes.
Median?
That's also well, okay. You all are a bit going ahead of the class. Good. Okay, hold on to that. Mean, median, good. A display, a picture, yes. Okay, that's good. Okay, okay, bar graph, it is made of bars. Anyone have the more technical term for that kind of bar graph? 3 syllable, yes. Very good. Just have you heard of that? The histogram, right? Histogram is bars, right? Now the reason why I didn't say that bar graph is the exact term I want is because a bar graph actually is a specific picture for categorical data. We'll get to that. Yes, a histogram is made of bars. But we know, right? But even the word bar has different meanings, right? It can be a place to go get drunk and all that. Okay, but the point, the point, the point is the technical word for the display for this histogram. Anyone heard of any other display for data like this? This one I would be very impressed if you knew. Anyone heard of a thing such as a dot plot? Have you heard of that kind of thing? It's just dots basically. There are advantages to a dot plot, but we'll get to all this. You can use a dot plot. A dot plot basically draws a dot when the data was on the axis. See, right? But we'll get to all that. So how would you display data like this? Well, you can use a histogram, you can use a dot plot. Now, what does a histogram tell you? Well, a histogram is a sequence of bars that give you basically the groupings of where people are in terms of their heights. So a histogram tells you a couple of things. It gives you a sense of where the middle is of a distribution of data. It also tells you how spread out your data is. If your histogram has many bars spanning left to right, then your data is quite spread out. If your histogram is very peaked in the middle, then it's not very spread out. So histogram has various uses. It gives you some sense of where the middle is and gives you some sense of the spread of your data. Now's your chance to tell me what statistics can you calculate from your sample that give you some sense of the middle value. That's where all your M words come in. Mean, median. Anyone have one more M word? Yes, very good. See, they're all M. So it's quite nice to learn statistics. There are many reasons, I would say, there are many advantages to learning statistics in English. One of them is there are a lot of good mental alliteration. I think that's the word I want, right? Help you to remember stuff. Very good. There's mean, there's median, there's mode as well. Very good, right? So I hope you have differentiated between a numerical value, these are numbers, and a display. A display is a picture, but these are numbers. They both do different things. A picture gives you a visual representation of your data. That's what a histogram does. These numbers give you a numerical summary of your data. Okay. This is a nice question. What statistic could you calculate from your sample that gives you some sense of the spread of your data? Very good, yes.
The range?
Very good. Isn't the range something that will give you an idea of the spread? What's the range? Largest minus smallest. Now, there's a two-word, very famous measure of variability. I'm wondering whether anyone knows this. Yes. Very good. Yes, D. Very good. That's a number as well. You can't see it. It's a number. You can get something called the standard deviation. So at this point, please differentiate between these numbers and these numbers. These numbers tell you where the middle is, not spread. These tell you where the middle is. This tells you the spread. The range is the easiest to understand, I honestly think. The SD is a little bit more abstract because you can't see it, but it's a measure of spread. This one, I'll be super impressed if someone knows. Please don't be freaked out if you don't know, okay? That's what learning stats is for. I'm going to tell you next time. But does anyone know what IQR is? Okay, no? Now's your time to earn brownie points. No? Okay, so it's the interquartile range, just so you know. Okay? It is yet another measure of spread. Not important right now, right? Okay, anyway, so I want to differentiate between different kinds of statistics. There are things you use to see where the middle is. There are things you see or how spread out your data is. Okay, so a little bit of jargon. I think I'm going to stop here for slides because I try to vary things around. Let's do our first activity for today. This would be something which I wouldn't say is okay. I do promise you that I will teach as clearly as I can, but I do not promise you that every activity is going to be fun. Okay? So, I always tell people, not everything in life will be explainable in a TikTok video. Some things take a bit longer than okay, so but this is something certainly doable. So give this a try. So what am I asking you to do? Well, first of all, when I say group number, let me explain. That's actually not so important. Basically, try to sit in the same place each time, basically. But I do want to know who came today in your group. So members friends. So leave the group number alone. Now here's what I want you to do. Do you see a table here? And you see what I say? If you sample 10 Hope students and you determine each student's height in inches, write down some responses you may have. I want you to make stuff up. All right? I'm telling you, make stuff up. All right? And how many times do I want you to do this? For 30 people. 3 samples, each of size 10. Can you do that? Okay, so start. So fill it in. And then do number 2. Calculate the sample mean height for each of your samples. Can you also do that? Right? You'll need a calculator for this. I don't recommend doing these things in your head. Please don't do that. And then the most challenging of all is, can you find the standard deviation of your sample 1 height? I'll give you time. Start doing it, okay? First, make stuff up, right?
Yeah, I was there. Oh,
Oh, I forgot to say something. I have this thing called Scratchpad. When you have written down the numbers, I will invite you to go to our section 7 Scratchpad, the data Scratchpad, key in your made up numbers. I will start preparing that right now. You write it on your paper first, all right?
I'll know that.
61.
Now, humor me, I will teach you how to find these things automatically on Google Sheets. There is actually no need to do these things by hand. But this is your first stats class. There is some benefit to doing it by hand at least once. So do it by hand. I will later show you how to not do it by hand. All right?
I'll do the other one. Yeah. It's fine.
Yeah.
Okay, can I ask for your cooperation? As I said, fill in your samples, all your made up data. Every group just takes one batch, okay? Don't try, there's plenty of room. Right? Choose one. Report your sample one mean that you calculate by hand. Then we will use the computer to check and see if you got it right. Okay. So, and you know what? I'm going to also do one for the SD. And you just need to do this for sample one. All right.
Oh, that's cool. I'm a communications major. Oh, nice. Oh, are you?
Yeah.
Thank you. Exactly like that. Okay.
Oh. I like this.
Yeah.
Oh,
Thank you. This group has really gone all out and calculated all three means. You can, but you don't have to. Right? Because I know this is mind-numbingly boring. Okay, but we have to do it once, right? And one thing I like about group work is I get a whole lot of data very quickly because every group contributes just a small part. That's the best part. Okay, so pick a spot, start filling stuff in. Okay? Very good. Now the SD part, I gave a toy example here to guide you on how to do that. I will explain now how to find an SD. Again, you are never going to do this again after this class by hand, but just once. I'll tell you what. Do you see how an SD is found? Look at 3A. First, I say find the mean of the numbers. Find the mean first. Then, okay, I'll tell you the answer. The mean is 11.4. You will find that the mean of those five numbers is 11.4. But do you see what you do next in B? You take your original data and keep subtracting the mean and square it. Did you see that? What are you doing? You're finding how far away the data was, each one, from the center, the mean, and adding it up. This is a nice question which I would be very impressed if someone knows. Do you know why we square it actually? Why am I doing 2 minus 11.4 squared? 7 minus 11.4 squared. Why do you think I'm squaring? Because it adds more work for you to do. Can you think of a reason why? Why is the definition for standard deviation involving squaring these differences? Anyone can think of why? This is not an easy question. But I don't want to underestimate this class. Does anyone know why? Because some numbers are less than the mean, some are more than the mean. You'll get a mix of negative and positive. We are only concerned with how absolutely far you are. So that's why you square it to get rid of the minus sign. That's basically that is why. Okay? Then the last step is you add those things up, divide by one less the number of data points. So you have 5 data points, you divide by 4, then you take the square root. So I've broken it down without giving you a formula to tell you how you find it. So this is going to take some time, and this is being filled in very nicely. Try working on the SD for your sample 1. It is tedious, and please forgive me, but it has to be done once because you need to understand why the SD is defined the way it is. Because it kind of tells you how far away people are from their middle and adds it up like that. Now, I know that 10 data points is quite tedious, but just slowly work at it. Maybe you can do it in your group. So like you do the first 3, somebody does another 3, and then you just add up your answers together, right? Work together so it doesn't take so long, right? And I will reward you all later by showing you how you can do these things in just the simplest way possible using Google Sheets. Right? Right? I will show you how you can check your answer as well. Right? But see if you can do it by hand. Just once. Right?
That I just started writing. Because it's all. Oh.
Yeah. Um.
Oh, yeah.
So it'd be. So we do that for each one.
Yeah.
For like this, or just these 3. Dude, yours got off.
There's lots of space. If you want to show me your work, I encourage you to do that. All right? If you want to record what you're doing, please do that. All right?
Okay. Yeah.
So you don't have to find the means for 2 and 3. I want to spare you the word, just one, all right? Because I'm going to show you how to use software to do it. And the SD, please just do it for one, all right? Don't do it for any more than that. It takes a long time, all right? If you find that you, again, this you have to be honest with yourself. If you find that I don't know how to do 3B, then come see me. I'll help you. Because I know some of you are not the best when it comes to using a calculator. Because it's not as obvious as you may think. So like you have to press equals first, you have to get the answer first, then square, you know. So it's not as easy as just dumping everything in. So if you find that you don't know how to do this, or you're getting a different answer from your friends, then come see me. I'll help you. Bring a calculator, of course, right? Then I'll help you, all right? That's what office hours are for. Thank you. So I think I see a lot. I think every group has contributed, I think, what they're supposed to do. So I will do a little bit of consolidation because I'm going to plot some stuff for you to see. All right. I'm going to make a histogram for you. I'll show you how. Okay. I'm going to call it. Okay. I'm going to call it. Okay. Let's close the data collection. That's it. All right. So I'm going to just do this. I'm going to leave this alone because I don't think it likes having blank spaces when you make a histogram. So I'm going to have to play with it a little bit by getting rid of the empty rows. Okay. Okay. So let me just get rid of these empty rows. And I think that ought to do it. Okay. Okay. I have placed all the data together so that Google Sheets is happy. So here's what you can do, but I will be revising this. So please don't feel overwhelmed today. I'm not going to be testing you on this today. I'm going to show you how you can actually make a histogram very, very easily. Insert chart. Okay. Data range. Okay, no, I'm going to show you an even easier way. Let's kill this one. You know what you do? Select all your data first. Select all the cells. Insert chart. Okay, so it didn't do what you wanted. So you have to select the correct chart. So go to chart type and go look for the histogram, which is under other, this one. Did you see that? I'll come back to this next time. Okay. Why? Why are you doing this to me? This is not what I want. Oh. Oh, I think I know why. Let me see. It could be this. I think it doesn't like it because the data is not in one column. Let me see if I'm right. Okay. Let me see if I'm right. Okay. It could be that. Let me throw this away. Yeah, it could be that. It probably wants the data in one column like that, which is fine. I hope this fixes the problem. I think it will. So let me see. Okay, get rid of this. Okay, now let me select all the data and see, thank you so much. You generated so much fake data. Okay, so insert chart. Oh yes, okay. So that did solve the problem. Okay, that's that's a histogram. So this gives you an idea of all the made up data that the class made up. Where's the middle? Well, somewhere here. Now it's not symmetric. It doesn't matter. But the middle is somewhere here. Do you get some sense of the range of the data as well? Okay, stuff like that. Very good. Okay. Wait, 95 inches tall. Really? Okay. Okay, 30 inches tall. Really? Okay. You know how to have fun with. Okay. Okay. Anyway, so as I promised, thank you. Some of you really did it. Let's do the acid test and see if your calculations of your means were correct. I'm hoping that your means are okay. So how do you get a mean? You just type equals average. And please don't worry, I will be revising these things again and again. And you select the cells that you want to find the average of, which would be this. Oh, good, right? Kind of high stakes, right? So that's correct. And we can check. Okay, I'm not going to check. Okay, but if you want to check, you can check everyone's answers. Okay, so I need to do this. I'm sorry because I'm trying to plot another graph. Okay, so right, now please ignore these because there's nothing to calculate. So I'm going to take them away. Oh, very good. Wait, why was this missing? Hold on. Oh, great. Mostly okay. And there's one or two. Okay, never mind. Don't feel bad. We don't know whose group is what. So anyway, here are your means. Okay, what about the SD? Okay, that tedious thing. So go to another empty cell if you like. Equals STDEV. Again, I will revisit this many times, but today is as good a time as any to introduce it. All right? Gives you your standard deviation. So go to citadiv and citadiv this. Okay. Okay, so that's it. Suggested autofill. You know, you can, if you don't wanna, you just go to that small dot there and bring it down. So let's see. You know, you should pat yourself on the back. If you really did this by hand, this fantastic. You did the tedious thing and got the right answer. That's awesome. It is not nice to do. I hated doing it when I was in school, right? I don't do it by hand now. But the point is, that's how you check your answer. Okay. So, just to recap, there are a few things I want to differentiate with the class. First, do you see the difference between actual data and summaries of the data? Summaries come from a sample, you know. See, 10 people generated one mean and one standard deviation. But I guess my other question to you is this. Do you see that even the means are variable? Are they all the same? No. Now, here's a question I want to ask the class. Do you think the original data is more variable than the means are variable? Who displays more variability? Original data or summaries like the means of the data? Anyone can guess? Who's more variable? Actual data or summaries of the data? Yes.
Summaries
Or summaries are more variable or less?
are more variable.
Okay, so who thinks summaries are more variable? Who thinks summaries are less variable? Okay, and majority wins. Okay, not because majority wins. Majority was actually correct. Summaries of the data, like the mean, are more stable. This is very important, and I'm leading you somewhere, I promise. Right? That's why I'm talking about these things right now. Actual data can be very variable, but the means are less variable, and I'll show you. I'm now going to copy all these calculated means. Okay, I'm not going to talk about SDs right now. Here are all the means calculated from your fake data. And I'm going to paste them here. And I just want to paste the data without the formula. So paste special values only. Please don't worry about these things, okay? I will, as we go along, this is class number 1. So I don't expect you to know very much what I'm actually doing. But today, if you can get the main ideas across, that's already good. Okay, here are all the means that we generated from the class. That's why I asked the class to do that many samples. I'm sorry, but okay. Do you know what I'm going to do? I'm going to draw a histogram of the means now. Because means are, in a way, a new kind of data set. But these are of summaries. So I'm going to select this, insert chart. Okay, so wrong kind. So I want a histogram. So other, okay. Okay, it's 2025. You're living in the age of AI, but still stupid things like this happen. Okay? It did not know what chart I wanted. Okay, and that's what I want. Do you see something? First of all, is this a histogram? It's a histogram of the means. Are means less variable than actual data? Look at the range. This range goes from 50 to 75. But look at the range of the original heights that you made up. It went from 30 to 95. Did you see that? So you were correct. Means are less variable than actual data. Okay. So with all that in mind, I think you all are ready to do this. Okay. Yes. So WS1 means worksheet 1. In worksheet 1, was there variability in the height data? Just say yes or no. Or circle yes or no. The answer is of course. Yes. Was there also variability in the means that you computed from group to group? Answer is also yes. Was the variability in the raw heights greater than or less than the variability in the means that you computed? Circle the right answer. Okay, you don't have to tell me now. I just want to later when I collect it back, I'll see whether you got it right. Is the variability in the actual raw heights greater than or less than the variability in the means that you computed? Okay. So definition, the spread of data is called the standard deviation of the data. Well, technically there are other measures of spread. Every time I say spread, I think of peanut butter. I don't know why. Maybe I'm hungry or jam or something. Oh, maybe you can answer me this because I'm not from America. What is the difference between jam and jelly? Why do you have two words for that? Oh, really?
It's like the thickening agent.
Oh, okay. So who's thicker?
I think it's jam. I think jam is thicker and jelly is less thick.
Really? Because
It's like gelatin versus like pectin. Like it's a different like thickening agent.
this is so awesome. I was today years old when I found out. They said, why it's called jelly? Because of gelatin.
Yeah.
Okay, so, see, I thought I was going to teach you something, but okay. But anyway, okay, so there are other measures of spread, but the main one is the SD. Okay, the spread of data is called the SD. Now, here's an important definition. The spread of things like the mean is not called the SD, it's called the standard error. How many of you have heard this word before? Somewhere in a past life. Okay. Or before hope, right?
Repeat it.
Standard error. Has anyone heard standard error before? Oh no, okay. Standard deviation, yes, of course, right? So I'm teaching you now. Standard deviation is reserved for data, spread of data. Standard error is spread of statistics that you calculate like the mean. Remember that, okay? They are both spreads, but they are for different things. Okay, so I'm going to introduce you to what's called a Galton board, but First, I will show you a simple one first. This video it's not a whole lot of fun, but it's okay. So let me show you this, okay? Oh, no, not this one. I want to show you this one first. Okay, so let me hopefully copy this and show you what I mean. Okay, now this is me in a supermarket back in Malaysia. That's where I'm from, by the way. And they had this yogurt thing that they were promoting, just like in Costco. So we have that. But I don't know why they made this device that, I'm a statistician. So I said, this is too good to let go. So I played it and I recorded a video of myself doing it. Now I want you to pay attention to what I'm doing. Here's the sound. Okay. Now, I want you to look at what I did. Notice that I'm always throwing it from this middle of this. Pay attention to where the ping pong ball went. Okay. Where did I always? Sorry, that's so lame. I know, right? But I can't. I feel like I do as a reason. So, did you notice I always drop the ball from the same place? But did the ball always land in the same place? Okay. So let me ask you this question. I'll show you another one. Now, actually, this thing is what we call it's actually a Galton board. So I'm going to ask you this. A real Galton board actually has way more balls than what I have. I only had one to deal with. But imagine I built this structure that can collect all manner of these things and I throw them in and it goes down and lands somewhere. I can see I've accumulated some red balls here already. I just had the one ball there, so I couldn't do that. My question to you is this, and it's actually found on your worksheet. Okay. What do you think is the eventual shape formed by the many balls as they accumulate in the Galton board? Can you answer me that? This is based on whatever intuition or past knowledge. Anyone dare to try? Not dare to try. Anyone want to try to answer this? What I'm saying is this. You saw me throw that thing down. Sometimes it landed on the 3. Sometimes it landed on the 4. I think there was once it landed on the 5, something like that. My question is this. This is an accumulation of all these red balls falling. If I did this like 10,000 times, you see the ball entering here. What shape would these form? Yeah. Very close. Not a triangle, but we're getting very warm. Anyone? Yeah. Yes. Yes, you took my punchline away, which is what I wanted, right? You get a bell curve. You actually do. All right. So now I will show you a proper, not the mall kind of Galton board. I'll show you one that you can actually see what has been suggested is true. You do see this. Eventually, the Galton board, if you did this enough times and you always start from the middle, the way it is constructed is it will produce a bell curve. Why is that so important? Because actually, beyond being fun to look at, the Galton board uses statistical theory to tell you how means behave when you sample from a population. I'll say this again. You have all of hope right now here. And if you went out and talked to people and found out how tall we were. Like what I asked you to make up. Didn't you compute a whole bunch of means? I know they're all fake data, but you had this mean and this mean and this mean and this mean. If you did this thousands of times, the different means that you got, if you plotted a histogram of them, you would get that bell curve that I was talking about. Really. And so it is very bizarre that we can predict what eventually kind of means you see when you resample and do this again and again. That's what the Galton board is trying to do. That's what we call simulation. Okay? So can you answer some questions? What do you think is eventual shape? Bell curve. That's the answer. A bell curve. When you throw a ball into the center column of a Galton board, is it more likely or less likely for that ball to land eventually far away from the center? Give it a try. I said this all by completion. I want to know what you think. Listen to the question again. When you throw a ball into the center of a Galton board, is it more likely or less likely for that ball to land eventually far away from the center? Yes.
Less likely.
Very good. Less likely. Can it happen? Yes, you saw it, even in that supermarket one. But it's less likely to happen. Good. When you throw a ping pong ball into the center, is it more likely to land near the center? The answer is yes. All right, good. Okay. When you collect a sample from a population, are you more likely to get a mean which is near the center of the population? Yes. See, you've got it. The Galton board is replicating what happens in real life when you go sample means from a population. And when you collect a sample from a population, are you more likely to get a mean far away from the center or less likely? Less likely. Good. So the moral of the story is this. There is variability in all data, and even the means that you get from a population are variable. But how do those means behave when you do it repeatedly? They actually are distributed according to this Galton board bell-shaped curve like that. And we're getting to this one. So look at the picture I have. Now it says here number of ping pong balls in red zone. Now, of course, the picture is not in color. So let me give you the color version of that, which would be here. Hold on. The color version is here, so that we can look at it together. Yeah, worksheet 2. Look at my picture here. This is in color. So you see, that's the Galton board. What are these 81 and 72? These are just arbitrary numbers I picked to mean the center is at 81. And this is where I just draw a line, and this is 72. Remember that mall one has 1, 2, 3, 4, 5, 6? Yeah, this is 81 and 72. That's it. The middle is 81. Number of ping pong balls that fell in the red zone is 232. The number of balls in the board is 1,000. So this is an easy question. Near what number would most ping pong balls ultimately get to? Near which number? 81 or 72?
81.
81. Can you calculate as a decimal the proportion of balls that fell in the red zone? I know for some of you, this is like, what kind of class is this? This is insanely easy, and it is. But I don't want to assume. There are people who don't know what this means. So if you don't know what this means, please come see me for office hours and I'll help you. Can you calculate as a decimal the proportion of balls that fell in the red zone? Yes.
23.2.
Oh, that would be right. As a percentage, as a decimal? Yes. Okay. As a percentage, it is 23.2%. Can you tell it to me as a decimal? All right. So, do you know how to go from one to the other? Right. I used to write this down for my students. To go from a percentage to a decimal, you divide by 100, and to go from a decimal to percentage, you multiplied by 100. That should help. So 23.2% good is the percentage of balls in the red zone. Very good. But it's 0.232 as a decimal. They're the same thing. But I wanted this as a decimal. Very good. I think this is an excellent place to stop. But let me ask you first. Is there anything not clear about what I said? And I try to give a take home every class. There is variability in all data. There's even variability in summary statistics like the mean. But who is more variable? Is the data more variable or the mean more variable?
Data.
The data is more variable. What is the name of the spread measurement for data? Spread of data is called, it's two words. Standard deviation. What is the spread of statistics like the mean?
Standard error.
Very good, standard error. So standard error tends to be smaller than the standard deviation. And in a Galton bond, you are much more likely to be near the center than to be at some edge somewhere because of the bell curve characteristic. Very good, thank you very much. There will be a homework today. It is entirely based on this and some arithmetic. I'm going to give you a week, but I really hope you don't take 1 week to do it, right? Because the point is to address, it's like a self-diagnostic thing. If you find I don't know how to do these calculations, you need to come see me for solving. All right, and I will talk to you. I won't score to this. Okay, I know some professors can be intimidating. I'm not that type. All right, so please come see me. Come see me early so we can address these things. I'll see you on Wednesday. Thank you.